Welcome to T1 Academy. In this video, we are going to discuss the second part of our cubes and dice. In the first video, we discussed about the dice things, students. One is closed dice, open dice, and how we are going to see and how we are going to solve the problems we have seen in our first video. Okay, how we are going to solve the problems we have seen in our first video. Now, in this video, we are going to discuss about the most important concept, that is cubes. Cubes, how the questions will be asked, and in general, see students, even though the questions are based on topic name is cubes, sometimes they may also ask us about the cuboid also. What will happen? So, before moving to this cubes and cuboid, students, I want to tell you one basic thing which is very important for us. What it is if recently they are asking questions based on cuts. Cuts. Sir, what is this cuts? For example, see here students, this is one face of a cube. This is one face of a cube. Now, if I make one cut here, how many pieces it will become? It will be broken into two parts. Two parts. Now, similarly, when a cube is there or one face of a cube is there, I made two cuts. Then how many pieces it will become? It becomes into three pieces. And similarly, there is a cube. I will make three cuts here. So, how many pieces it will be broken into? It will be broken into four pieces. Now, see here students, usually they will say that two cuts they are using recently. Two cuts along length, breadth and height. When you make two cuts along length, breadth and height, tell me how one face looks like. Two cuts, sir, along its length I made. Assume this is along its length. Next, along its height also I made. So, how many pieces it will be broken into? 3 by 3. 3 by 3. So, please remember students, the number of cuts, the number of cubes formed after the number of cuts is, see here, write down this simple assessment. A cube is cut into small cubes such that two cuts, or instead of two we will go with n cuts along its length, breadth and height, then the number of small cubes are equal to, n plus 1 into n plus 1 into n plus 1, which in turn I can write it as n plus 1 whole cube, Recently they are asking questions based on this cuts. So, please be careful in case of the cuts. Now, similarly they are asking us regarding questions based on cuboid, not only cuboid. So, what they are telling is there is a cuboid which was made two cuts along its, two cuts for your understanding, two cuts along length, or three cuts along length, two cuts along breadth and one cut along its height. Then the total number of small cubes thus formed are, see, three cuts means along its length it will be broken into four pieces. Two cuts along breadth means into three, and one cut along its height means 2. So, the total number of small cubes will become what? 4 into 3 into 2. Actually, what is happening here is 3 plus 1 into 2 plus 1 into 1 plus 1. How we are writing n plus 1 into n plus 1 into n plus 1? Here also the same thing, 3 plus 1 into 2 plus 1 into 1 plus 1. So, please try to understand this cuts. So, number of cuts. If it is directly given, if the question is directly given, later we will see the direct cases, it is fine. But if the question is related to cuts, so always the number of small cubes formed on one face will be one more than the other one. Understood? So, This cuts concept is very, very important. Recently in all the examination they are trying to ask question based on this cuts only. Cuts only. Now then later we will see the remaining cases. Now this is the basic understanding, students. Now next, now I will move to the cubes concept. Now I will move to the cubes concept, and then later we will see the remaining things. Now what is a cube, students, in general? What does a cube contains, or else in general what is a cube for us? A cube will have how many faces? 6 faces, sir. Okay. A cube will have 6 faces. 6 faces. So I will draw a cube. A cube will have 6 faces. A cube will have 6 faces. A cube will have 6 faces. Now, okay, a cube will have 6 faces for me here. So instead of that, let me do one thing. We will draw it very clearly. A cube contains how many faces? 6 faces. How it looks like this, right? Okay. Intentionally I am drawing like this. Later we will draw it perfectly. No need to worry. Right? Like this I will have cube. A cube will have how many faces? 6 faces. Top, bottom, side, front and back. Front and back. Okay, cube we know. Now see here, a cube will have how many corners? Tell me, students. Corners. This is a corner, 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 this one, this one, this one. These are called what? Corners. These are called what? Corners. These are corners, students. Okay, these are called corners. We will see what is the importance of these corners, faces and all those things later. A cube will have 6 faces. We know what is the face means. This is a face, this front, side, all these are what? Faces. Like this total we will have 6, and these are corners. Next, how many edges we will have for a cube? Now see here, students, these are called edges. These are called edges. These are called edges. So for a cube we will have how many edges? For a cube we will have 12 edges. Sir, how 12? Top 4, bottom 4, 8, and this one 9, 10, 11 and 12. So total for a cube we will have how many edges? 12 edges. 12 edges. 12 edges. Now 12 edges, right? Now see here, based on front and back, tell me the relation between, see, overall 12 edges will be there. Yes sir, we will have 12 edges. Now the combination of top and bottom with the sides, how many we will have? Okay, later colors, with the help of colors I will try to tell it. No need to worry about that one. So total a cube have 6 faces, 8 corners and 12 edges, right? This is clear for everyone? Yes sir, this is very much clear. Okay. Now what is the importance? So what is the importance of these corners, edges and this one? Now please see here, students. Once please observe this one. What is this cube called? This is a corner cube. Earlier we have seen, right? This is a corner cube. Now tell me, this corner is shared between how many phases? How many phases? Top. It is shared by this top. Assume this is a front. It is shared by this front. And this is side. That means a corner is shared by 3 faces. A corner is shared by 3 faces. A corner is shared by 3 faces. Understood? Right. Okay, sir. Corner is shared by 3 faces. Next, when it comes to edge, what are edge here? This is an edge, right? This completely is an edge, but I am considering only this one. So here in this edge, this cube, this is a top and this is a front, right? And this is a top and this is a front. Same cube, right? Top and front, same cube. Yes sir, top and front the same cube. So this is top and front. So that means a edge is shared by how many faces? Shared by 2 faces. A edge is shared by how many faces? 2 faces. An edge is shared by 2 faces. Now this middle portion this middle portion, we call it as face. We call it as a face, right? Front. This into mark 1 are shared by only front portion only, right? So that means a face is shared by one face. A face is shared by one face. A face is shared by one face. Only one face. Edge is shared by two faces. Corner is shared by three faces. And the face is shared by only one face. Now, similarly, we will have a core portion, right? That means the central core portion. Core portion. Can we see the core portion of a cube anywhere here? No, we cannot see the core portion. So that means the middle cubes. We cannot see the middle cubes. We cannot see the middle cubes at all. We cannot see the middle cubes at all here. So a corner is shared by three faces. Edge is shared by two faces. A face is shared by one face. Okay, sir, good, well and good. We understood that one. Now, put this concept aside. Now come to this one. There is a huge cube. Assume there is a bigger cube. Big cube. Big cube. It was painted with a single color. It was painted with a single color. I will take an example and I will try to solve it. Okay, now see here. A big cube of side 5 centimeters is painted with a color on all the faces, and then cut into small cubes of size 1 centimeter of side, instead of side, I is painted with of side 1 centimeter. Then we will see the different cases, students. Now see here, there is a bigger cube. It was cut into. See here, students. What is the actual side of the bigger cube for me? 5 centimeter side. It was clearly mentioned in the question. Next, it was made into small cubes of side what? 1 centimeter. That means how many cubes? First of all, tell me how many cubes it will be formed here. On each face 5, 5, 5, right? See 1, 2, 3 and 4 and 5. 1, 2, 3, 4 and 5. It will be divided like this, 5 by 5. Why? Because this is total 5 centimeters. Now each one will become what? 1 centimeter. 1 centimeter, 1 centimeter, 1 centimeter like this. How many it will become? Now please see here how many cuts we made actually. We made 4 along its length, 4 along its breadth. Please be careful. Cuts made 1, 2, 3 and 4. 1, 2, 3 and 4. But it was divided into 5 parts. It was divided into 5 parts. So please be careful with that cuts, students. That is the reason each and every time I am mentioning that cuts. Okay, 1 centimeter and 5 centimeter. It was cutted like this. So now tell me what is the total number of small cubes formed? Total number of cubes formed. If you make an n by n into n 1 to 1 into 1 into 1 means what it becomes? Total number of small cubes will become n cube. That is 5 cube. I will get how many in number? 125. N cube. Total number of small cubes will be 5. That means what actually I am doing here? I am cutting them in the manner of 5 into 5 into 5. N into n into n. That will become what? N cube, which is 125 small cubes. 125 small cubes it will become. Okay, sir, 125 small cubes. Now, the same thing, assume this is the 3-dimensional figure of that one. See 1, 2, 3, 4, 5. 2, 3, 4 and 5. Right? This is the 3-dimensional assumption of that cutting. This is the 3-dimensional assumption of that cutting. Now, before cutting, what we have done here? Before cutting the figure, what we have done? We have colored all the faces with a color, with a single color, Now, when we paint it, now please observe here, ma. After, first I painted it and then I cutted it. Now see here, this is a cube, right? For this cube, how many faces the paint will be there? 3 faces. Why? Because this is located at corner. Now this is a cube. For this cube, for how many faces the paint will be getted here? I mean, for how many faces the paint we will get the paint here? We will get the paint on 2 faces. Why? Because these are on edges. And these are face cubes. For how many phases for these cubes we will get paint on? One face. Why? Why? Because they are presented face. Now see here students, a corner cube. Why we are getting three faces painted means it is there at corner and it is shaded by three faces. Because of that reason we will get the paint on three faces. The edge cubes are shaded by two faces, then obviously the cubes which are present on edges will get paint on two faces. The cubes which are placed on face, they will get paint on only one face. Two and one face here. Like this we will get the paint on three faces of the cube. Okay. Now see here students. Now usually there will be some cubes which will not get paint at all, right? Why? Because the core area, the middle portion will not get, they will be cutted. See, take an example of cake. That will be very easy for us. Now see here, for a cake, what we usually do generally, we will have cream, right, on the cake. When we cut it into pieces, will the middle pieces get cream? No, right? Why? What is the reason, sir? Why? Because we are applying the cream only on the outermost layer, right? We will apply cream only on the outermost layer. So there will be no chance of getting, see, if you add the cream layer by layer, that is secondary. But I am telling in a generalized manner. So in a cake, we will get cream on only the topmost layer. That means only on the top pieces you will get the cream. But what about the pieces which are present in the middle? They will never get a cream, right? Right? Similarly, here also the same thing. The cubes which are present on the outermost layers, they will get paint on one face, two face or three face based on the places they are located. But what happens to the core cubes? It remains unpainted. Now the core cubes will be how many numbers are? Now see here, this row will be gone, this row will be gone, and this row will be gone, and this row will be gone. So now the core layer will be what? On each side I am losing 2, right? 2 here, 2 here, 2 here. So the core area will become what now for me is n minus 2 into n minus 2 into n minus 2. This will be my core area, my core, where I will have cubes, but they will never get paint at all. They will never get paint at all. Now this one only, we will solve it little bit differently, students. Now see here, I will take the help of this one diagram and I will try to tell you. Now please observe here, we will write some generalized formulas and then later we will see the things which you need to by heart it. So usually, but try to understand this one, students. Now cubes, number of cubes with three faces painted. These are always fixed, that is 8, but for your knowledge sake I am explaining this one. Now I have taken only one face, alright. I have taken only one face. Now where do I have corners? 1, 2, 3 and 4. These 4 are corners, right? So in one face how many corner cubes I can see? 4. Okay sir, 4. Like this total how many faces I have? 6 faces. These are number of faces and corners in a face, that is 4 in number. So corners in a face, number of faces by 3. Sir, why I am dividing it with 3? Why? What is the reason, sir? Means one corner is shared by 2 faces. One corner is shared by 2 faces, sorry, 3 faces. That is the reason I am dividing it with 3. So now what happens to this? 3 1s, 3 2s, 4 2s are 8. So irrespective of the number of pieces which we usually cut, the corner cubes will be always 8 in number and the number of cubes which get paint on 3 faces will be always equal to 8. That is the first one. Next, number of cubes with 2 faces painted. Now see here, which cubes will get paint on 2 faces, students? The cubes which are present on edge. Now tell me what are the edge cubes here for me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. These are the edge cubes for me. Yes sir, these are. That means in one face I can see how many edge cubes? 12. So that is 12 into, like this total how many faces I have here actually, students? I have total 6 faces. 12 into 6 by, each edge cube is shared by how many faces? 2 faces. Earlier the corner is shared by 3 faces, so I have divided it with 3. Now the edge cube is shared by 2 faces, so I am dividing it with 2. So 2 ones, 2 threes. So total how many cubes will have get paint on 2 faces means 36 cubes will get paint on 2 faces. 36 cubes will get paint on 2 faces. Okay, see here students, these 2 cubes, 2 faces painted will vary based on the number of cuts which we make generally. Corners remains the same, that will be always 8 in number. Number of cubes which get painted on 3 faces will be always remain same, that is 8 in number, but 2 cubes it will vary based on the number of cuts which we make. Please be careful with that one. Next, number of cubes with one face painted. With one face painted. Now tell me which cubes will get paint on only one face? The cubes which are present on face. So how many face cubes are there for me here? 9 face cubes are there for me here. 9 face cubes are there for me here. So 9 into, like this, total how many faces? 6 faces. 6 faces by 1. Why 1, sir? Why? Because each face cube is shared by only one face. So 9 6 are 54. There will be 54 cubes which get paint on one face. Now, as I already told you, there will be cubes which will not get paint at all. So the cubes which with no paint, the cubes with no paint, that is equal to, in different ways we can do. One is total minus 3 faces paint plus 2 faces paint plus 1 face paint. This is one method. So what happens if I do so? Total is how many in number? 125 minus 3 faces painted are how many in number? 8 in number. This will be 8 in number. This will be 8 in number. So 8 plus 2 faces painted. 2 faces painted are how many in number? 36 in number. And 1 face painted. 1 face painted are how many in number? 54 in number. 54 in number. So what happens to this one, students? Overall 125 minus 98. So there will be 27 cubes in the core area which will not get paint at all. So instead of doing all these things, the simple method is, see here students, each phase is divided into 5 5 5, right? Now anyway this one and this one will be deleted like this. So on each side 2 rows will be deleted. On each side 2 rows will be deleted. That means we can directly write 5 minus 2 into 5 minus 2 into 5 minus 2. That is 3 into 3 into 3, which is also equal to 27. This is the other method of finding the number of cubes with no paint. Understood? Why I am writing, sir, instead of writing 5 minus 2 whole cube, why you are writing each and every time means, see, this is a cube, so we are doing like this. If the same thing happens with a cuboid, then the number of sides will not be equal, right? So that is the reason each and every time I am writing it separately. Now the same things I will show you in a conditional manner. Now see here, in a cube there are 6 faces. Yes, a cube is a 3-dimensional figure having 8 corners. Yes, and 6 surfaces or faces. And 12 edges. We discussed already about these things. Next, in a cube, length, breadth and height are same, while in cuboid these are different. We already know it. Now next, see here, in a cube, number of unit cubes, that means small cubes will be equal to side whole cube. That means 5 into 5 into 5, right? Unit cubes, 1 unit cube. So unit cubes will be side whole cube. That means if the side is 5 units, and if you cut it into 1 small units, so our answer here becomes what? 5 cube, similar to our last example. So if the side is some 6, then how many unit cubes I will get here? Unit means 1 unit cube. So 6 cube we will get 216 in number. Like this we will have unit cubes. Unit means just see 1 centimeter, 1 meter, like that. Usually in centimeters only we will have. So 5 centimeters 1 into centimeters, like that. Okay, units in cube. Next, see here, total number of cubes. That means small cubes will become how many in number? N cube. 0 painted face means what? No face painted. N minus 2 whole cube. I just now we have written, right, n minus 2 into n minus 2 into n minus 2. These are formulas for that. Single painted, 6 into n minus 2 whole cube. Single face painted, 6 into n minus 2 whole cube. Why means one face. See, only one face we will take and two rows will be deleted. So, 6 into n minus 2 whole cube. And similarly, two faces painted are how many in number? 12 into n minus 2. 12 into n minus 2. You can use the formulas directly. You can use the formulas. 3 are always same, that is 8 in number. See, why 12? 12 edges. Why 12? 12 edges. So, 12 into n minus 2. Why 6? 6 faces, but n minus 2 whole square. N minus 2 whole square. Here it is n minus 2. See here students, it will keep on decreasing. 3, 2 and 1. Powers are decreasing. 3, 2 and 1. Okay, 3, 2 and 1. Okay, please keep on. These are formulas, but usually these formulas are little bit confusing. That is the reason we solved it in the general manner earlier. Okay, next. See, it is if it is in the game of cuboid, P, Q and R, cut into cubes, then total number of small cubes, n into n into n, here will comes P into Q into R. Next, zero painted means P minus 2 into Q minus 2 into R minus 2. Earlier, n minus 2 into n minus 2 into n minus 2, n minus 2 whole cube. Here, we are subtracting 2 from each. Next, see here, single face painted. Now, 2 times of PQ, 2 times of QR, 2 times of PR. Okay, combinations. Here also the same thing. So, 2, 2 and 2. Now, here we have painted, two sides painted, 12 edges. So, 2 edges with P, 2 edges with, 4 edges with length, 4 edges with breadth and 4 edges with height. Length, breadth and height, 4 edges. Okay, next, painted, this always remains same, whether it is cube or cuboid, it doesn't matter. So, those are 8 in number. Understood students? So, just have a look. This is very, very important for us. There we will write directly 6 into n minus 2 whole square. What is the reason is, there P and Q both are n. So, if P and Q are both are n's, what happens to this one? N minus 2 into n minus 2, n minus 2 square. N minus 2 square, n minus 2 square, n minus 2 square. So, 2 times of n minus 2 square, 2 times of n minus 2 square, 2 times of n minus 2 square, what it becomes? 6 times of n minus 2 whole square. So, that is the same reason, 6 times of n minus 2 whole square. Now, here also the same logic applies here and that one. Everything. So, cube and cuboid are similar. Just please be careful while taking this n and PQRs. Okay, now we will solve some questions, students. A cube of each side 4 centimeters has been painted black, blue and red on pairs of opposite faces. Okay, we are painting not a single color, we are painting 3 different colors on opposite face. It is then cut into small cubes of each side 1 centimeter. Small cube of each side 1 centimeter. Okay, now how many small cubes will be there? How many small cubes will be there? First of all, total number of small cubes. 4 units is cut into 1 unit, right? So, 4 into 4 into 4. So, how many I will get here? Total 64 small cubes. Total I will get how many? 64 small cubes. Now, we will see a diagram of that one, students, later. Now, one second. I will show you the diagram. Now, see here, students, like this. We will paint. Just for your knowledge, students, for color combinations. Tell me how many green and yellow combinations I will have. How many green and yellow? This is one combination. This is another one. Why? Because opposite will be yellow. So, green and yellow on top 2, on bottom 2. So, whenever alternate, opposite faces are painted like this with 3 different colors, like this one. So, now please see here, green and yellow. Yellow edges will be 4 in number. Green yellow edges will be 4 in number. Next, red and yellow edges will be 4 in number. And similarly, green and red will be in 4 in number. So, total 12 edges, they will be divided in this manner. 4 will be green and yellow, 4 will be red and yellow, 4 will be green and yellow, green and red. Like this, the things will be segregated. Please be careful with this. different colors concept. Now we will see the questions. Now see here, how many small cubes will have 3 faces painted? How many small cubes will have 3 faces painted, ma? Same, it will always remain same, that is 8 in a number. There will be no change there. Next, how many small cubes will have only one face colored? See here students, all the are blue color, then it is cut into 125 equal small cubes. 125 equal small cubes means n cube is equal to 125, right? N cube is equal to 125. Then what will be n, students? N will be equal to what? 5. N will be equal to what? 5. That means I will cut in this format, right? 5 into 5 into 5. I will cut in this format 5 into 5 into 5. Now they are telling only one face colored. Now because of that reason only I told you the general method. Only one face means draw one face, students, so that you will have a clear idea and very quickly you will solve it. See, one face painted means this one, right? This 9. Like this, total how many faces I will have? 6 faces. So 6 into 9. So I will have how many? 54 cubes which will be painted on one face. Or else you can use the formula also. What it is? 6 into n minus 2 whole square. 6 into n minus 2 whole square. N minus 2 whole square. 6 into n minus 2 whole square. So 6 into 5 minus 2 whole square. It will become what? 6 into 3 square, which is 9, which is 54. Anyway, you will get with the formula, you will get the answer, or with the general observation. But what my suggestion is, students, try to solve it with the general observation. Why? Because during the examination, in the examination hall, sometimes it will be difficult to recollect the formulas. Why? Because throughout our journey, we will learn multiple formulas and there is a high chance of getting confused. Because of that reason, please try to understand this general concept. Then later anyway with the formulas, if you are really good in by-hearting or remembering the things, that is secondary. You will by-heart it or you will remember it and you will simply substitute it. But at the same time, please try to get the answers in the general format, which is very, very important for us. Okay, right? Next one. Now see here, all the opposite faces of a big cube are colored with yellow, red and green. Okay. After then it is cut into 216 small equal cubes. See here students, what does he mean here is n cube is equal to what? 216, sir. N cube is equal to what? 216. Now what happens to my n? 6. That means on each side I have cut it into 6 1, right? Now see here, how many small cubes are there? One face is green and the other one is either yellow or red. One is green and the other is yellow or red, right? Now see here students, already I told you, out of 12 edges, how the combinations will be there? 4, 4, 4, 4, right? That means, see here students, yellow and red, one combination, red and green is one combination and yellow and green is the other combination. So they will be equal in number, right? So they will be 1 ratio here, 1 ratio here, 1 ratio here. First, irrespective of colors, assume that find out total how many cubes are there which will get paint on 2 faces. Generally, only 2 faces. Okay, where one face is green and the other. That means here only 2 faces are getting painted here. One is green and the other can be anything. Right? So first, that means here we should understand the basic concept that here I need to find the number of cubes which get paint on only 2 faces. So if I go with the general concept, first 1, 2, 3, 4, 5 and 6. Okay, 1, 2, 3, 4, 5 and 6. Now first I will find how many cubes will get paint on 2 faces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Okay, so 16 I got. Like this, how many faces? 6 faces and each way edge is shaded by 2. So 2 3s are, so 16 into 3. I will get 16 into 3. Now see here, intentionally I will write that I will have 16 with red, yellow and red, 16 with red and green and 16 with yellow and green. Understood? 16 into 3. Instead of dividing it later, first multiplying and dividing, I am writing here. That means I will get 16 of yellow-red combination, 16 with red-green combination and 16 with yellow and green combination. Now green are where do I have green? Here and here. And the other can be either red or green. So total how many in number? 32. So my answer here becomes what? 32. My answer here becomes what? 32. My answer here becomes 32. Very simple one if you understand the concept. If not, what happens is students usually they will try to count these, that and everything. So simple, try to understand the concept very clearly. We will have 4 edges here, 4, 4, 4. That means equal ratios we will have, right? So 1:1:1 ratio, equal portions. So 16, 16, 16. So like this we will solve it. Or sir, I remember only the formula, not this one. Go with the formula. What is the formula I have? What is the formula I have? Where I get two faces painted. Where I get two faces painted, 12 into n minus 2. 12 into n minus 2, right? So 12 into n is what here? 6. 6 minus 2. So what I will get? 12 into 4. That means overall I will get 48 cubes which get painted on two faces. This 48 should be divided into 3 parts. So 48 by 3 means what? 16. So 16, 16, 16, 16. The same thing. Combination. 16, 16. 16 will be red and yellow. 16 will be red and green. 16 will be yellow and green. So the same thing. So 48 by 3. 16. Like that also you can find it. Just you should know the combinations. That is very, very important for us here, students. Okay. Now that is the reason. See, this is 6 by 6. Yes, this is 6 by 6. This is 6 by 6. How many edges I have here? If you keep on counting, it will waste a lot of time, and usually that is not a suggestible one. 1, 2, 3, 4. Right? So like this I have on one edge I have 4. Total how many edges I have? 8. 8 4s are 32. Like that also you can do it. Just count it for edge as an edge. So total 80 edges will be there for me. 8 into 4, 32. Like that also you can do. But it will be little bit confusing if you are not drawing this diagram perfectly. Okay, please be careful with that one. Next, all the opposite faces of a big cube are colored with OK and so on. Okay, small cubes are, there are no face whose no faces are colored. That means what? The core cubes. Core cubes. So 216 small cubes means what, students? N cube is equal to 216. So n will become what? 6. No cube painted means what you will write? N minus 2 into n minus 2 into n minus 2, right? No cubes painted. Earlier also we have seen this one formula. So what it becomes? 4 into 4 into 4. This will be 64 in number. So there will be 64 small cubes which will not get paint at all. There will be 64 small cubes which will not get paint at all. See here, students, here two things I am teaching. One is the general one and the other one is with the formula. So please try to observe here. Okay, in general we will solve it with the general case and formula by combining. Then only it becomes easy, right? These are the things for us, right? Okay, these are the concepts based on the cubes. So please be careful with that cuts. Cuts, once again I am telling. One cut will make you into 2, will give us 2 cubes, 2 cuts to 3, like that. And please be careful with the cube and a cuboid. Anyway, whether it is a cube or cuboid, it will be cut into small cubes only. Remember this one. Okay, thank you very much.